Okay, grade 8, now we're going to be talking about construction of geometric figures. We're going to start off with this video, which is bisecting lines, and then we're going to get to bisect angles. It's important to understand these two videos before we can get on to how to draw a triangle, how to draw quadrilaterals, and the different degrees without or with using your protractors, your compasses, and your rulers. So in these videos, I encourage you to get a piece of paper out, get your ruler, your protractor, and your compass if you have, and really practice and do the examples as I'm doing them with you. We're going to really get in depth when we talk about these two videos. Okay, so bisect means to divide into two equal parts. So we have a line, right? We're going to call this line A. We draw a line across it. We're going to call this line BC, right? If I put these two arrows or these two lines through this is to say that the length from here to here is exactly the same as the length from here to here. So here we can say that line BC is bisected in two by line A. If we had a look at this line, we put a D, we put the two lines across an E. Now it's two lines to show that it's a different length to this, but it's still the same length as this line here. So here we can see that from the line to D is the same as from E to the line. So this bisects these lines perfectly. If we had to draw this line, FG, it doesn't look like it cuts an even, but if we read what it says that is 3 and that is a 4, which means that this length here is different to this length here, meaning that this is not bisected. So this is not a bisector. We could look at this line here, H and I, and see I've put 5 lines now to show it's not the same length as anything else, but that this length is equal to this length. And we see that this is a perpendicular bisector, right? So perpendicular bisector. Remember that that square means perpendicular, which means 90 degrees. So how do we perpendicularly bisect a line? Let's put our line A and B across. We have a point somewhere on the line. Right. AB is equal to 10 units. We know that. So we put C at 5 units. We say AC, this is C here, at 5 units. This is halfway between the line. So we take our compass, that is this instrument here. So we use this tool and we extend it more than halfway, place it at the point B, and we draw a circle with that compass. So we draw the circle here, and you can see our circle. You know how to do this. Then we're going to do the same. Keep the compass the exact same length and do it again from the other end. So we're going to draw a circle on the other end, right? Now you'll see that we're going to place a ruler across the arches, these 2 points here, where the arches cross. We're going to draw a line segment. And this is our line we're going to put here, right? Now, this is a perpendicular line. It's a bisector, so these are both the same lengths. These are equal lengths, and now we can see that this is a perpendicular bisector. We've drawn a straight line at a right angle or 90-degree angle. Okay, let's have a look at some examples. I have these two lines, A and B, C and D, and O is my origin, where they cross. So the length of AB is equal to 16, and the length of AO is equal to 8. Does DC bisect AB? Okay, so we know AO is equal to 8, and we know that AB is equal to 16, so it is logical that if that is true, then this is equal to 8, BO. So that is BO. That makes sense, because BO plus AO must equal 16. Okay, so does it bisect? So does DC bisect AB? Does DC bisect AB? Yes, it does. Those lengths are equal. Okay, let's now look at another example, or another question. We have DO is equal to 3, that's this value here. And then we have CO is equal to 6, that's this value here. So this here is equal to 6, that's from there to there. Right, so does AB bisect DC? Does AB bisect DC? Oh, you can quite easily see that it does not cut this in half. This length is not equal to this length, so it does not bisect. Okay, let's draw another line. And we call this line, we call it EF, and we're going to told that O01, so origin 1, is 3. So now this is 3. So if this is 3, and we know that that is 6, we know that that must equal 3. So these two are equal to each other, which also happen to be equal to that, but don't worry. And then we know that EF is equal to 5, so EF is equal to 5, okay. We know that OE1 is equal to 2.5, oh brilliant, so that's 2.5, 2.5, that is equal to 5. So these two lines are equal to each other, okay. And then we know the angle of EO10 is equal to 90 degrees. Oh, brilliant. Right. So does EF bisect CD? Does EF bisect CD? No, it doesn't, because we have 3 on this side, and then we have 3 plus 3, 6 on this side. So EF does not bisect CD. It doesn't cut CD in half. Does EF bisect CO? CO, yes, you can see that EF does cut CO in half. There's a 3 and a 3, so yes, it does. Does CO perpendicularly bisect EF? Now does CO perpendicularly bisect EF? Does CO cut EF in half? Yes. Is it perpendicular? Yes. So yes, it does. Well done, grade 8. That's just bisecting lines. Again, the next videos are very important as they're really going to get into how to draw these shapes properly and what it all means.